Hi, continuing with solving algebraic equations using algebra tiles. So what about 3x equals 12? Once again, you know what? I'm going to actually give myself a little bit more space. Okay, once again, you divide that right over there and imagine one side of the line to be one side of the scale and the other side to be the other side of the scale. The purpose, your goal is to never tip the scale. So if you do one operation to one side, you have to do exactly the same operation to the other side to keep the scale balanced, because the algebraic equations is a balanced model. Okay, so 3x. So remember that we did those big tiles. Well, I don't have the actual tiles, but so we represent this as x, and I have 3 of those. Okay. All right. And on the other side, I have 12. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so remember the goal is to isolate 1x. So because at the end, I want to know what 1x is. I want to know that. So what we are going to do is, okay, so what can I do? If I divide this by 3, so 1, 2, 3, then you can actually separate 1x. So at the end, you will have 1x on one side, right? Okay, so I have to do, if I do one operation to one side, I have to do exactly the same operation to the other side. So I divide this side into 3 equal parts. And you can see that here, 1, 2, 3. I can divide this into 3 equal parts. So on this side, what do I have? What I have is I have 1, 2, 3, 4. I have 4 because I have 1, 2, 3, 4, right? So I know that the answer to this question, x equals 4. So if I'm just writing out as an algebraic equation, so 3x equals 12. What did I do? I divided both sides by 3. 3x divided by 3, 12 divided by 3. So I'm doing the same operation to both sides, and that gives you x equals 4. Okay, so not too bad. Okay, on to the next problem. What if now it is like this? What if it is like what does that mean? How can I represent this? So that means, this means half of x, right? So once again, divide that. That means I don't quite have 1x. I have half x, and I don't have the other half. This whole thing is x, but I don't have the whole x. I only have half of it. And on the other side, I have 4. I have 1, 2, 3, 4. Okay, so what do I need to do? I have to have 2 pieces of this in order to actually get the full x. So I want to have the other part. So that means, if I'm writing it like this, if I'm adding the other side right over here, if I'm actually making this part into existence, you can see that if the half of it makes up 1, 2, 3, 4, can't you see that? Okay, this part is, yeah, it is 1, 2, 3, 4 positive tiles on this part. Same amount, 1, 2, 3, 4. And you can see that if I have the whole x, 1x, then I have 1, 2, 3, 4, 5, 6, 7, 8 positive tiles. So x equals 8. And how can I actually write that down as an algebraic equation? So what we did here was we actually multiplied this part by 2 because I needed not one piece but 2 pieces. So 2x, I am multiplying by 2. So if I do one operation, what do I have to do? I have to do exactly the same operation to the other side. So you multiply that by 2 as well. So you can see x equals 8. Okay, so that's how it goes. And I'll be back with more algebraic equations a little bit later. Thank you.